our group will be presenting question 5 for FAD 1008. And we are HJ1. Our group members consist of one Izul, Nurul Khalisa, Nurin Alisa, one Farid, and Nur Kisna Imani, and I am Nur Kisna Imani. So first of all, based on this question, we need to identify what is the hydrocarbon. So how do we identify the compounds? So let's refer to the next slide. Referring to the question, it is given that hydrocarbon A and B are isomers and contain 85.7% of carbon. So we need to identify what is the hydrocarbon by dividing 85.7% of carbon with its molecular mass, which is 12.0 gram, and we get 7.14 mole. And it will be the same for hydrogen and obtain 14.3 mole. Next, we divide by lowest molar quantity, which is 7.14, and we get its empirical formula, which is CH2. And that's how we prove that hydrocarbon A and B is an alkene.
Okay, since we know that hydrocarbon A and hydrocarbon B is the isomer, so we can justify that hydrocarbon A is cis-but2-ene while hydrocarbon B is trans-but2-ene. Here is the structural formula for the hydrocarbon A and hydrocarbon B. Okay, for the next reaction, ozonolysis of both compound A and B give a single organic product C. So, as we know that compound A and compound B is a but2-ene. When it undergo the ozonolysis, it can form the intermediate product, which is butane ozonide. And when it's completely undergo the ozonolysis, the final product is ethanol, 2 molecules of ethanol, which is the product C. Okay, to justify that compound C as an ethanol, we can refer to the equation that it states that oxidation of compound C, which gives the carboxylic acid, which is compound D. So, as we know that oxidation of an aldehyde, which will give the carboxylic acid. So, we can conclude that compound C as the an aldehyde, which is an ethanol.
Next, oxidation of compound C gives a single product, a carboxylic acid D. So, since we know that compound C is an aldehyde, it is true that the oxidation of an aldehyde will produce a carboxylic acid. So, since compound C is an ethanol, we can conclude that the oxidation of ethanol will give ethanoic acid and water as the products. To prove that compound D is ethanoic acid, we can refer to the question. It is stated that according to spectral data of hydrogen atoms in D are contained in metal groups except the one in carboxyl group. So if we look at the structural formula of compound D, we can see that the structural formula actually fits the description. Therefore, we can conclude that compound D is actually ethanoic acid, or commonly known as acetic acid. In a separate experiment, it is found that A is polar whilst B is non-polar. So since we know that compound A and B are both but2-ene, we can say that A is cis-but2-ene while B is trans-but2-ene. So why do we say that? For compound A, which is cis-but2-ene, it is polar because it has two metal groups on the same side of the double bond. Therefore, it will contribute to the electronegativity of the carbon atom attached to the metal groups, and as the result, it will create a dipole moment. Meanwhile, for compound B, which is trans-but2-ene, the metal groups are on the opposite sides of the double bond. Therefore, the charge on the both sides will be balanced, and it will lead to the lack of overall polarity of the compound. Therefore, it makes the cis isomer is a polar compound and the trans isomer is non-polar, and this fit the description of compound A and B. And we can conclude that compound A is cis-butyene, meanwhile B is trans-butyene.
Next, from the question, upon reaction with cold neutral potassium permanganate, A gives only a meso compound E. As we can see, compound A, which is cis-butyene, reacts with cold neutral potassium permanganate, produces compound E, that is meso 2,3-butanediol, and which is also a meso compound. Compound E is meso 2,3-butanediol. We can prove that it is a meso compound by converting the 3D notation of this compound to its Fischer projection. From the Fischer projection, we can see that it has a chiral center, but it is achiral due to its plane of symmetry. We can draw the line of symmetry at the middle, and we can see that the upper and lower part of this compound is the same. That means it's symmetrical, thus proving this compound is a meso compound. Next, B gives a racemic mixture of F and G. We can see from this reaction, compound B, that is trans-butyene, reacts with cold neutral potassium permanganate, gives off compound F, which is 2R, 3R butane 2,3-diol, and compound G, 2S, 3S butene 2,3-diol. And we can see that compound F and G are racemic mixture. This is because they are equal quantities of two enantiomer, and they have disymmetric molecular structures that are mirror image of one another.
So this is compound F. Compound F is 2R, 3R, 2,3-butanediol. As you can see here, there are two hydroxy group attached to the carbon, which shows that it is butanediol. So that is how 3D notation and Fischer projections shows compound F. For compound G is 2S, 3S-23-butanediol. So there are two hydroxy group attached to the carbon, which shows that there is butanediol. So the difference between compound G and compound F is the position of hydroxy group that attach to the carbon, which shows that they are racemic mixture. For reaction of B with bromine in carbon chloride give a non-polar compound H. So compound B is trans-butyene, so it will react with bromine, will produce meso 2,3-dibromobutene. So this is compound H. Compound H is meso 2,3-dibromobutene. So this is how the drawing of 3D notation and Fischer projection of compound H. Compound H is a meso compound because it contains two identical stereocenter. It also has internal symmetry plan that divide the compound into half. So these two halves will reflect to each other.